Bounds. Okay, the one topic many people are really afraid of and don't want to cover. Well, what if I told you finding up and low bounds is pretty dead easy? Okay, but of course the calculations can be a bit tricky. So let's just make one thing clear. So firstly, when you're taking a measurement, and you should consider that a measurement is rounded to a given unit. Okay, for example, to the nearest centimeter. So the actual measurement can be anything up to half a unit bigger or smaller. So we're going half up or half down to wherever the measurement is. So let's take an example. So suppose that the mass of, say, let's just go over cake, is given to be 2.7 kilograms, some nice delicious chocolate cake that you might go for your birthday, to the nearest 0.1 kilograms. Okay, not so bad. Find hence, and we might need to find the interval, i.e. the upper and lower bound. So firstly, this means therefore, by the way, the lower bound is always going to be firstly the weight itself minus the half the nearest unit. Okay, so half of 0.1 is 0.05. Okay, and the upper bound is the same thing, 2.7, and it's going to be half a unit bigger, plus 0.05. Doing the maths on this would give you 2.65. This would give you 2.75. And that's it, guys. Literally, that's what you do. And then you say, hence, the interval is of, the actual mass of the cake lies somewhere between, is not equal, 2.65 kilograms, which is less than or equal to, let's say, m, which is the mass, less than 2.75 kilograms. Again, less equals be here because it has to be, because when you round up 5, this will go to 2.8. We got to stay within. So this is just, for example, this is just less than 2.75. This is less than equal 2.65. Okay, but yeah, that's really it. If you just half this unit, so half of 0.1 is 0.05. Alright, so let's do a nice actual exam style example, okay? So, look at this one. Grade 7, so this is big boy stuff. Now, consider that a table is measured as being 0.88 meters and 1.32 meters long to the nearest centimeters. So let's just say cm. So in this case, we can straight off the bat say that we're looking at half of centimeters, so 0.5 up plus minus for bounds centimeters. Remember, treat this as 1 centimeter. Okay, nearest centimeter. So firstly, calculate A, the minimum and maximum values for the area of the table, and B, give the area of the table to an appropriate degree of accuracy. So this will be done after this. So let's do part A first, yeah? Let's look at part A. So I hope you guys are doing this and solving as I am. So first things first, let's find an upper and lower bound for the width. So the width is going to be, you're going to subtract 0.05 on this, you're going to get a lower bound of 0.88 take away 0.5, which is, oh, so centimeters. So remember, this is in meters. Okay, so this is, we should know 1 meter is 100 centimeters. So this is 88 centimeters. So this is going to be 88875. Okay, and the upper bound is going to be 0.885. Okay, same thing for the length. It's going to have a lower bound and an upper bound of the same style. So you're going to plus minus a 0.005. So you're going to have 1.3, 30. So if it's 32, it's going to be 31.5. And if it's 32, 32.5, up and down. Okay, so now we got the lower and upper bounds for both. Hence, the minimum value for the area, so the lowest possible area, is going to be when we multiply the two lower bounds. So what we're going to have, so the minimum would be 0.875 times 1.315. And if you put this in a calculator, 0.875 times 1.315, you should get exactly 1.150625 meters squared. Okay, and again we do the same thing for the maximum. Now then we find the maximum of this table, pick the two largest values because that's how big that's the biggest they can probably be, and we should get some similar result, a bit bigger of course because this is a maximum. So what do we get here? Well, I got 1.172625 meters squared. So you guys probably got the same, okay? Yeah, looks quite legit. Now let's move on to part B. So B, give the area of the table to an appropriate degree accuracy. So this is basically here and off this question. So we look at the two areas, and we notice we got 1.15, 1.17. I mean, if I round this to one decimal place, we'll get the same kind of answer. So the safe assumption is to round this to 1 dp. So rounding min to 1 dp will give us 1.2 meters squared. Why? Because we look at the 1 dp and this is our decider. Bigger than 5, so this goes up by 1. So yeah, and the max is the same thing, to 1 dp. 7 is also 5 or bigger, it's also 1.2 meters squared. And that's it, guys. So we can safely say that to one decimal place, the area of the table is approximately 1.2 meters squared. And that's it. Hope this is clear for you lot, and ciao for now. See you in the next episode. Adios.